welcome everybody to this December, I guess the last one of the year, Carney Conversations. It's been a really a lot of fun for Chris and I to do this over the last several months, and really appreciate all of the audience questions. And so we're just going to go out with a bang here in 2020 with David Badre, and very excited to be talking to one of our close colleagues here at Brown. So as you everybody is signing on, you know that you're here for a Carney conversation about how the brain gets things done, and we all are keen to know how to get that brain working more efficiently and on task. As I'm just want to give you a couple of kind of logistics. This session is going to be recorded, and it's going to be available through the Carney website eventually, once that recording gets dropped onto our website. But for now, as audience participants, we're really relying on you and really feed off of your questions, which you can put in at any moment during our introductions, and as David and Chris start to get into some more detailed questions about his new book, On Task. And you can do that through the Q&A function. The chat is disabled, so you won't be able to use that, but please go to the Q&A function. And then Chris and I will get into your questions and pose those to David. Great, and so I've already mentioned Chris, but Chris Moore is here with me to talk to David about his book and his research, and obviously David Badre is the reason that we're all here. And I'll give a quick introduction to David. So David Badre, a close colleague of ours, is Professor of Cognitive, Linguistic and Psychological Sciences here at Brown. Early in his career, he graduated with a bachelor's degree from University of Michigan and his PhD in Brain and Cognitive Sciences at MIT, and then he did a postdoc at UC Berkeley before he joined Brown as an assistant professor in 2008 and has moved up the ranks. David focuses on cognitive neuroscience of memory and cognitive control, with an emphasis on frontal lobe function and organization. He is a winner of several awards, including the Alfred P. Sloan Foundation Fellowship in Neuroscience, the James McDonald Scholar Award in Understanding Human Cognition, and the Cognitive Neuroscience Society Young Investigator Award. David has a very active research group here at Brown, and I'm sure that he'll be talking about that as we get into some of the questions. But he really focuses on human cognitive control of memory and action, and employs a number of different methodologies, including behavioral testing, functional magnetic resonance imaging, and computational modeling, to really assess cognitive function, executive actions in humans. So David, welcome. Thanks for being here.
Yeah, thanks so much for having me.
Yeah, you know, we're going to talk around this topic, of course, but I do want to mention the launch and congratulations. It's a huge effort, I'm sure, but congratulations on the launch of your new book called On Task through Princeton University Press. You know, I know Chris is going to reiterate this, but I just wanted to say how incredibly accessible your book was. And, you know, this is not my area, cognitive control. But I don't know, like, I love the way that you, in your writing, you just had, at least I felt I was just slipping into the topic kind of effortlessly, but always with this, you know, at the end of the chapter feeling, oh, I just learned something I didn't know, but I can relate that to myself. And so you have this brilliant way of introducing complex topics, but in a way that you're always touching on things that the reader can really individually relate to. And I'm sure that was the intention, but I really wanted to call that out. And there are just so many fabulous quotes. I mean, it's been a long time since I got my pencil out and started to underline many paragraphs in a book. Sorry for those of you who hate the idea of writing in textbooks, but you know, that's me. And I just wanted to mention one quote, and then I'm going to jump into a question for you. But in your introduction, really, you're really acknowledging how difficult it is to define what you're actually doing in your research. It's like, you know, and I thought that was just done brilliantly well. And of the many quotes, I just thought I would just mention one, which was really at the heart of, you know, it's remarkably difficult to define cognitive control. It's like intuitively you know what that is, but how do you actually define it? And you've got to define it to study it. And you say that it's cognitive control processes live in the murky spaces between knowledge and action, influencing the translation from the first to the second while not being either one. And I just, you know, it's kind of like, you know, when I first read The Hobbit, and I was like, oh, these murky spaces, and then what is this about? And I don't quite know, but it's so interesting. And you're just like slipping everybody into it. Anyway, it was one of my favorites. On to getting you on there, less about me, but tell us about what motivated you to write this book, and how did you stay on task?
Well, thanks, Diane. I appreciate you highlighting that quote. Actually, I mean, I think that's part of what makes this an interesting area to study, right? Is that it is this, it's this mystery, right? That's at the heart of you know, basic human ingenuity and flexibility and intelligence. And so that's sort of what motivates, I think, people who study cognitive control, myself included, right? Is that it's so mysterious, right? But in terms of writing the book, so I did it probably the way you're not supposed to do it. You know, most people, they start a book on a sabbatical or someplace where they have enough time to do it. I took the path of not really knowing I wanted to write a book, and I spent my sabbatical though doing a lot of reading of books. It's, you know, it doesn't feel like scientists do this as much anymore, but at one point, you know, it was a lot of major ideas, particularly in cognitive science and in cognitive neuroscience, were put forth in books. And so I went and read just a bunch of books, both modern ones and earlier ones, and I really was inspired by that process. And so it took me about a year to get inspired enough to agree to write a book. And of course, at that point, when I finally signed my contract, my sabbatical was over. So that's not the way to do it. That's one tip to any aspiring authors out there. Don't wait till your sabbatical's over to start writing your book. The longest possible time before you'll have time again. But then I think I think I said to you earlier too, the reasons to start writing the book often be very different than the reasons that keep you going with the book. But the thing that I guess kept me going over that time was it was a chance to really engage at scholarship at a level that we don't usually get to. A lot of what we do in writing technical papers is, you know, they're topical, they're on a particular point that you've been investigating, and you know, you try to treat that topic. You should do it really individually. You connect it, but that's not the main goal. Whereas the goal of a book is to really try to take a step back and think at a bigger picture level. And then this also was a chance to introduce a topic that I don't think at least in cognitive neuroscience, cognitive control, I haven't seen introduced beyond specialists in the field previously. There's been a lot of course on memory and decision making and related topics, but really I think this particular topic is less familiar, and I think it's really essential and important one. And so it was a great chance to do that too, as you know, as not just a scientist but also a teacher, a chance to do that, which was, I think, very motivating.
Yeah, I think this is so great because there is that, you know, when you are an expert, you are the expert in the field. It's almost counterintuitive that you say, well, I'm going to write something that's going to be accessible, and in doing so, you get deeper and deeper and deeper and deeper, you know, into your field, and you've got to really read widely in order to be able to understand the context in which, you know, your research is going to be accessible, but and understandable by a broad audience. But you gain so much in that process, and I think I've never written a book like this, not sure I'm compelled to
You
do
should.
it, but no,
It's a
no,
good
no, no, no.
experience.
But I guess my point is that I admire it, and it's the same in teaching, right? When you're teaching, you learn so much yourself, and then you understand what you don't understand, which I think is just brilliant. So thank you. So Chris, I'm going to move over to you, and we'll start to get into the nitty-gritty of being on task.
I liked murky better than nitty gritty. Actually, murky implies truly Dagobah, like kind of, as opposed to maybe Tatooine. So I gotta say, David, like as someone who, I always consider myself the slowest reader on the planet because I get so stuck when I'm reading things. And the number of times I've picked up your book and I tried to spot read it, like I try to read everything, like just dive in here and I'll just take that out. And then I'd look up and I'd be 20 pages later and I'd have been sitting there and yeah, pulling out my pen to underline things because it's just fascinating. And it's just so well written. Like you really need to be careful. You're going to just write books for the rest of your life. You're not allowed to stop being a professor and just go do that. Just so that's clear. I mean, one of the things that I found really interesting, and maybe this is, I don't know, a route into what you call the murky space between knowledge and action, but there's a bit of an adventure story in that you're in that murky space, the cognitive control space between the two. This is something that has vexed psychologists. I mean, it vexes me on a daily basis. And you explain how I can make my cup of coffee every morning, which I appreciate that you finally brought some reason to daily actions. Like Dan said, you capture that really well. But there's also a bit of an adventure story to how this has vexed psychologists for so long, is getting their hands around or their minds around this problem. I don't know if I mostly would like you to help us understand what that murky space is, but I found it really interesting to see ways in which in the history of, we're finally able to make progress on this in really systematic, clear, organized ways in a way that historically that wasn't possible. So there's almost a bit of an adventure story to this moment in history with the book. So I really want to know about start explaining the space between knowledge and action, but for me, going into that through the history of it was really useful and interesting. Like all these things I thought I knew about behaviorism, I'm like, oh, that's how that fits with where we are now in the knowledge.
Maybe it'd be helpful just to sort of say what we mean by cognitive control. Like, what is the book about? So I think there's two things to sort of recognize about human behavior that makes it really interesting to me, at least as a scientist. It makes it a big mystery, right? So one thing is that we're able to conceive of goals that we have, like just on the fly, and they can be big goals, like you want to start your own business or something, but they can also be really kind of everyday goals, just like you mentioned, like going and getting a cup of coffee or doing something like that. And yet we can conceive of that, something we want to do, and we can then on the fly assemble the actions we need to do it. And it doesn't require, in our case, thousands of trials of training to get that task in place. It doesn't require years of evolution, right, to give us the instructions. We're able to sort of do that translation. And the reason is because we have a general purpose system of cognition that can do that, right? We can sort of assemble these things on the fly. And then the second piece to understand is that our mental life is really complex and teeming. It's actually hard. It's easy actually for scientists to miss this because we spend so much time, like in my lab, we design experiments that are deliberately simplified and reduced, and we try to keep keep people kind of focused on one thing or another. But if we really take our everyday existence, moment, you take a snapshot of us at any given point in our day, our minds are bustling and teeming with different types of goals. We have different, there's something we're sort of postponing for later, something else we're doing right now. Then it occurs to us we need to check our email or something, and your social media dings at us. And if it's during the pandemic, maybe you heard your kids that you're trying to homeschool somewhere in the background just got off Zoom and they need something. And so it's you're also there's lots of different threads to the structure of our behavior, right, that are happening at once, and somehow the brain has to manage all of that. And so the why I think it's interesting, right, is that it's actually a really hard problem. We sort of take it for granted. It doesn't, the fact that all of us, I mean, a great example is the fact that within a week or two, all of us radically changed our behavior back in March and April. I mean, we were doing things in ways we'd never done them before as a as a society, right? We're doing things online because of the pandemic. We all start wearing, many of us, hope we wish it was all of us, start wearing masks routinely, right? We incorporated new behaviors seemingly overnight in an adaptive way. And we did it because of an abstract notion that this was something that would be good to do, so forth. And the reason why that's a hard, and again, we do that, and it doesn't feel like a big deal to us, but we have yet to be able to program a general purpose artificial intelligence can do it, and it can do it. And there's no other species that does it at the scale that humans do it. And so it's a really interesting problem. And I think that, I mean, to your point, the fact that the history of it though is that it was something that was missed by scientists for a long time, right? The fact that you could, it feels to us intuitively that knowing should be enough. Like if I tell you the rules, right? I tell you, okay, you're gonna, I tell my kids, you should start wearing a mask now every day. They should start doing that immediately, right? If I have that in mind, because they know it, and if they don't do it, it's because they either didn't know it, or didn't really want to do it, or didn't really, didn't understand the reason for it or whatever. And those things can be true, certainly. Motivation matters a lot. We could talk about that. But there's also a point at which you have to, if you have a goal, you have to be able to assemble the actions to do it, and that's not trivial. And that's a big problem. And it turns out it actually affects a wide range of human activity. So that's why the book is sort of broad, is that it's trying to cover all the different ways in which that ability to bridge knowledge with action, right, is important, and the mechanisms by which the brain tries to do it.
I love some of your examples in the book of, like, you're telling Maria, or whoever, whatever name you use for the daughter, right? Don't touch that really disgusting thing. All right, and then they touch it. And like that ability, they completely understand what you meant, and they have the ability to not move their hand, and there's just this gap between the two. And it could come from many places, but the fact, it is genuinely exciting. I don't know, as someone who loves discovery, right? To be at this moment when we're finally able to put real bones underneath the structure of what feels murky to us, right? Even those of us who are way overscheduled and overplanned, my internal life of what those parts are, like what the parts of being able to make a plan like that, I kind of know. I make lists or something. Like I know that there's a process with it, but like actual introspection doesn't usually yield for me very good insight into what those components are, right? And it feels like we're finally getting real traction on the components. There's so many places to go with the conversation, but one that's well, maybe actually the best would be just, can you give us a sense for those components? I mean, you mentioned that motivation matters, of course, and memory matters, but can you give us a sense for the components that go into, like, bridging that gap between knowledge and action with the really rich space we live in?
Well, there's a lot to that, obviously, but I think one of the things you need is a way of bridging, or you need a representation that can bridge between the two, that can link between explicit goals and so forth. And so we have, what's an interesting, and so if you think about like a simple example where you need control. So for example, if let's say you're in I think I gave the example in the book of you're in your car and your phone buzzes. So under normal circumstances, you weren't in your car, right? Your phone buzzes. That might be a cue to check your phone, right? So that's a very automatic, highly programmed action over thousands of trials of checking your phone, and for better or for worse, right? And so it's a really compelling thing. If your phone buzzes, you want to check it. But if you're driving your car, if you know things about distracted driving, it's really a bad idea to check your phone right then, right? That's a very dangerous thing to do. And so you need to use this context, right, of driving in order to stop what you're doing. So one of the key components that has to happen there is you have to maintain that state, right? That context of the fact that, and the rules that of driving have to be held in what we would call a working memory, right? So that means in sort of an available state where it's available to use as a system to say, I'm going to override this tendency to check my phone, and instead I'm going to focus on the road, or ignore it, or come up with something else. Maybe even choose another course of action that's more like you're going to think about something else explicitly or something. Okay, but regardless, that has to happen, and so it turns out that a really important important, that's its own structure. Like how we decide to update that in the brain really matters. And there's some nice evidence, and a lot of this comes actually from work also from Michael Frank, who's here at Brown as well, who suggested that that this actually it evolves out of an ancient system in the brain for basic motor control, right, through the basal ganglia, right, that allows for, you know, candidate movements, even in simple organisms, right, it's actually, these structures are shared among all vertebrates. It goes back to the lamprey, actually, that we, like our ancestor that we share with the lampreys. It's a very old and ancient system for moving, right, that says that allows for an action to be proposed in the brain, and then through disinhibitory loops through the basal ganglia, that can be amplified in order to act. And if you think about it, that's very adaptive, right? If we did everything we thought of, right, the moment like an action came to mind, you did it, right? Right, life would be just a stream of stubbed toes and awkward moments. And so you have so already there's an ability to control right there what movements you do based on an action, right? And so you can imagine that could be an animal waiting for the prey to be in the right spot to leap or whatever. That can be amplified and it can be dynamically timed. And in order to sort of scale that up to be able to do things like hold on to take the right action with your phone, depending on an abstract notion if you're in a car or not, you can use that same circuit dynamic to amplify, for example, when is that context relevant to your behavior, right, in memory, as opposed to just the motor movement. And dynamics or interactions among those loops can actually help you engage in control. And so it changes that problem, right? So now you're trying to learn what are the right dynamics of input and output to memory. What are the right dynamics of when do you need to update information? What information needs to be updated, and that would be most useful in this particular situation. And so that's one example of the kinds of structures. And it's not the only, but but that gives you a sense of the kinds of things that we focus on.
David, actually, if you don't mind, Chris, there's actually a question that links beautifully to your answer, and perhaps there's an opportunity to expand a little bit. And so someone is writing, you wrote that a working memory gate is a helpful metaphor for thinking about computation in a neural network like the brain. So can a gate also be thought more literally in the brain with the opening and closing of ion channels? No guess why I picked that question. But as I was listening to you, like that integrative necessity, at every level of a big function within the nervous system. Anyway, I kicked that out to you, and maybe combined question, if you hold that in your brain right now, are there examples of particular disorders that would be that you could mention just quickly to give an idea of what happens when one loses or affects cognitive control?
Well, that's a great question. The question of the gate, it's a very deep question, because I think it hits at a really important point here, right? That when we're talking about cognitive control, I'm talking about these basal ganglia loops. That's one example of an implementation of something like a working memory gate. So just so people know what we're talking about when we say a gate. So if you're in this car example, right? It's really important. You don't want to always be thinking about being in your car and always checking what you're doing, or you don't want to input everything that could be useful right in any moment. You need to be selective. Our ability to hold things in mind, our working memory, is very limited, right? It's like a few items at any given moment. So we don't want to fill it with useless things. So we need to sort of have some mechanism for controlling what goes in and out. And so that's often conceptualized as a gate, right? So when the gate's closed, information can't go in, or if you're holding something in mind, if it's closed, it's not going to, until you open it. When you open it, it allows that information memory to control whatever it is you're doing. Okay, so that's at the sort of functional level, the idea. And what I described in terms of these basal ganglia disinhibitory loops is one implementation of a gate. But I think, to your point, Diane, that computation, right, the idea of controlling propagation around networks could happen at multiple scales and have different implementations. And in fact, one interesting aspect of studying cognitive control, to me, is that you learn about fundamental computational trade-offs that actually hold in any system. And so if we took that gate idea, okay, for a moment. One of the things it solves is a computational trade-off between flexibility and stability. So for any network that I have, if the things I do to that network to make it more stable, right, are going to trade off on how well I can update it or make it flexible. And you know, you can think of, I think I give this example in the book as well, right? If I'm in my office, you know, working on a grant, because I'm, you know, a good faculty member and I'm working away on my grant, I can be very I can be, you know, very stable about that, right? I can resist, for instance, looking at my like Apple Mail icon that was where the badge is incrementing every moment as new emails are coming in, and that's a new task that I shouldn't be doing right now. I can be stable on my task, right? But I don't, and that's good. I mean, I'm not so flexible that I'm just captured by this other task. But the flip side of that is that I don't want to also be so stable that when a student from my lab comes in and says that, you know, hey, the servers are melting down, that I'm like, well, I'm going to keep working on my grant. I must stay entirely stable. I'm able to also flexibly shift as needed to a new task. So that fundamental trade-off exists at a functional level, exists in brain networks, it'll exist down to neurons, and it'll exist all the way up actually to societies and so forth. It's a basic trade-off. And the one way to solve it is with a gate, because you can divide labor. You have one system that's responsible for the stability side, and something else responsible for the flexibility side. And so in the brain, right, the cortex can act very much as it can help with the stability side of this by maintenance and memory. And in the example I gave, the basal ganglia would provide flexibility. But if you're talking about a channel, the mechanisms for opening and closing channels by separating them off from the stability in the of the cell, right, would solve that same problem, would confront that basic trade-off in the same way and make it
yeah, that's right system. Yeah, I mean, and in fact, you know, you could go all the way down to the gating of a single molecule and think about the chemical thermodynamics that are really defining that, and the Brownian motion of the bonds within that, and you get to that same place. And so all the way through the biological systems, triggering of an action potential, you know, right? You have a lot of stability there, but like you just need one at that moment in time. Yeah. So yes, I mean, it's just a beautiful representation across all levels of the nervous system. Do you want to mention a couple of disorders that really bring home an example of loss of cognitive control?
Sure. I mean, one thing I should say is that one reason why cognitive control is important to us is that it's affected actually in a wide range of disorders, like many both you know, mental health disorders as well as neurological problems result in problems in cognitive control. And what that tells us is that it's a very multifaceted system. This ability to bridge knowledge and action is pretty fragile. It depends on a lot of parts. Okay, and so you know, you can lose that ability, and with it, then you often lose independence and you know, has a lot of consequences in the complexity of your world, right? But two patients can show that kind of loss, but for very different underlying reasons. And that's actually one of the major research programs. You know, that's one thing that's driven my research for years. You know, the funding I've gotten through NIH and so forth, and I know it's other researchers here at Brown, is trying to understand at a core level, right, what is the you know, what are the pieces, right, what is of that multifaceted system, so we can better identify it. But you know, in terms of specifics, obviously, you know, disorders like Parkinson's disease, like ADHD, as well as any number of disorders of stroke, closed head injury, and even just, you know, specific degenerative disorders like Pick's disease and so forth, that it can affect the frontal lobe or associated systems within the whole frontoparietal control system, will end up likely having cognitive control problems. But as I say, it's really it's very widespread. It also something that's affected in healthy aging, right? As we get older, we tend, you know, cognitive control tends to, our capacity for control tends to change. And this is one of probably the major causes of loss of independence in very old age, right? But the flip side of that is cognitive control is also a source of strength and resilience as we age, because we can lean on our control systems to be adaptive, right, in order to kind of adjust as our body and mind is changing as we grow old.
Ending on that positive note. Great. Chris, over to you.
Well, again, there's so many strains here. And also the questions are just pouring in, which is fabulous. So we'll have to keep the question list and make sure you address them in some way. But when you have to address on your website, or maybe we can all tweet it out once you give it to us, well, your sabbatical reading list is something that's now been requested with great enthusiasm from one of the listeners. So I think you have to post that. This is the obligation of having framed your knowledge.
I'll definitely post it.
Great. So one question that came in is how you address the long versus short timescale question. To what degree is there something fundamentally different between assembling the components of making coffee versus like a 5 or a 10-year, let's say, career or life plan? How does timescale fit into this?
Yeah, that's a great question. I mean, there's a couple things. So one is obviously the this idea of temporal abstraction, of the fact that we need to, when we do tasks, we don't just do them in one moment, in one episode, but rather they unfold over time, right? And so even within medium to short time scales, the brain has to confront that problem, right? How is it that you can sustain? And that's actually where the notion of control really gains some theoretical teeth, right? Because it's something that's you're trying to maintain, even though you're going to deal with all kinds of things that change over time, right? You're still trying to do this task, right? This same task, whatever it is, over that period of time, and that has to be abstracted, and that's a hard problem. But maybe one thing that the scale that the questioner is asking, right, between like a very long-term goal, like going to college or something, versus making coffee, is the open-endedness of very long-term problem. It's very hard, right, to plan out, right, with a planning system, this sort of the tree of possibilities, right, that would unfold before you in order to, like, from now until like retirement. I'm going to plan out everything that's going to happen, or some future goal that you have. But it's so open-ended problems actually put more pressure on our control system, because they require constant replanning and monitoring and assessment, right? As you go, you have to take stock of where you are relative to your future reference point, replan, and then enact that plan. And that's those are exactly the places where we see, and I give a lot of examples of cases in the book to illustrate these points, but this is where you see patients have problems. One thing that we often kind of miss, I missed it until I went to my postdoc. One of the great things I did in my postdoc was actually test patients, because before that I thought that like a cognitive control and executive function was like Stroop tasks, and if people don't know what a Stroop task is, it's when you have to say the ink color of a word that names some other color, right? So you get the word red, but it's printed in blue, and you have to say blue, and that's really hard because you want to read the word, right? And it's a really common effect. But it turns out if I give a patient with frontal, with say a stroke that's affecting a wide portion of the frontal lobe, or had a massive frontal resection, if you give them a Stroop test, they show interference like everybody else does, but it isn't very predictive of how they're going to do outside of the clinic. Or if there's not a huge, they tend to actually be fine very often at those kinds of tests, and so this is one of the big paradoxes, of cognitive control. It's only in the complexity of world where there are these open-ended problems. You're trying to coordinate lots of things, and you have to go through this process of not just of kind of reasoning about where you are and trying to understand the structure of the world, right? Its causal nature, its associative nature, but then assemble the actions on the fly that you need to do that new thing you just thought of. That's where you see the breakdown most saliently. In fact, for years, they up until like the 60s, before we had a conception of cognitive control, the prefrontal cortex was thought of as functionless cortex, because all these patients would come in and have damage, massive damage, and would be fine on the clinical assessments.
Yeah, and I mean, do you have thoughts about how we bridge that divide then between the lived experience of the patients and what we can find tractable, in 4 square walls with a computer screen and a reaction time monitor? Are there strategies for?
Yeah, I mean, I think there are. It's hard. It's a hard problem. I think the strategy that we've taken for years has been, and I think this has been somewhat fruitful, is to try to identify not just the core functions like working memory gating and its operations, but also how they would scale with complexity. So you try to identify ways that they complex, and some way that you can, a general point, right, that allows you to draw inferences about how they scale, right? And so, and then you can try to, and then come up with predictions of how they would operate in those environments. But that becomes really important. I think something that gets missed sometimes is that scientists build these experimental models that are very simplified, and they really lend themselves to theory, and we can do great work in generating theory, but then we sort of never go to the next and say, okay, now how does this scale? What is it, and what are the principles that would allow it to scale? And I think that's something that's changed in recent years, and I think it's been helped by influence from other fields, including what we see in artificial systems and artificial intelligence and others that have really led us to start thinking about things like hierarchical reinforcement learning and big problems that really try to address complexity, the curse of dimensionality, and so forth.
This impinges, of course, on the general challenge in defining what to measure in psychiatric disorders, and the slowness of the introduction of therapies, effective therapies on the market. And we all wrestle with this, and I think Josh Gordon has been really fabulous. He's at the National Institute for Mental Health and really pushing for like a real quantitative framework around many of these disorders, but still you're going to see what you measure and you don't see what you don't measure. And I know that you've in fact, you and Chris and Michael have all written about this and thought about this a lot, but there's a bigger elephant in the room as well, which you're pulling on. So yeah, great.
Yeah, I think that the emphasis on, the term like computational psychiatry, for example, that's really that, and the RDoC framework from NIH is a great example of this, where instead of thinking about mental health only in terms of clusters of symptoms, right? Rather, these, you try to identify what are the underlying computational components, right? The structure of the problem that might be transdiagnostic, right? And so you might have two ADHD patients, right, that have different, they show the same symptom clusters, but for different underlying reasons, right? And that if you could identify those, and I think things like gating, the stability of the networks, right, and control. These are the kinds of underlying computations that are going to be fruitful, I think, as we start to understand more about them. Moving forward, at least I'm optimistic about that.
We're being fed by just some fantastic questions coming in, so I think I'm just going to continue on that. Maybe jump back to a discussion that you had earlier, and this is actually a plea for some practical advice. And so you can, as a parent of both of you. Mine are older now, but so to go back to you had this really great example of you tell your child not to do something and go ahead and do it, and like and then they can repeat back to you, and it's like, what did I just say? So this, but they can't seem not, they can't not do it. So someone is asking, well, and I would extend that to teenagers where the stakes are much higher, but what does your research tell you then about how to be more effective in eliciting the desired behavior?
From your kids?
David.
I don't know if I knew, boy. No, I can say, I'll say this though. I think what you're pointing at is true. That example, right? That we kids show a lot of what look like this. They show this knowledge action dissociation in lots of ways, but we have to realize that control is developing in children, right? And it's and that developmental process isn't just inert. I think there's a misconception that cognitive control or executive function, it takes a long time to develop. We know that, right? That there's this long maturational process. But that it's gonna kind of happen inextricably. Like, you have to give it time. It's complex. It's got to have time to wire up, and if just get out of its way, and it'll take time. Be patient. In the meantime, supplement everything that they do. But and it is true, they will get there eventually. But the thing I think that's a little subtly different is that the control system needs to wire itself up through data. right, that it's learning. The reason why it takes a long time to develop, I think, is not because it's complex. There are lots of complex things that wire up really quickly in the human brain. Vision is an incredibly complex problem. Perception, right? It's much more complex. It does not take until the second decade of life before you can see 3D objects or infer depth, right? The reason that control takes so long is it actually needs experience with both its system and the world around it in order to lay down these control policies. And so if you look at it that way, though I don't have advice to say like this is what will make your kids do this thing, I do think it's important that you give that children the opportunity to build a robust and control system. And there's data that suggests, for instance, unstructured play. Obviously you need to have lots of structured time for children, but unstructured time is really important. Time for children to try to set their own goals, not the goals we set for them, to set their own goals and then assemble the actions that they need in order to achieve that goal, and to safely fail. Right, and then get that feedback and try again, right, or come up with new strategies. And there's scaffolding you can do as a parent to try to help that, right, where you can set it up, provide some support, then back up and let them try. But I think it's actually, as a parent today, I feel like, and I was at a event yesterday at our school, and we had this similar conversation. It's very hard to find unstructured time for your kids. They're so scheduled, right, with things to do. And even when they're in, and on top of that, they're almost always being supervised in their play, right, and what they're doing. And so as a result, it's they don't really have those opportunities. You have to kind of make them. You have to be very, very intentional about letting them try to go out there and, mingle in you can't do it during a pandemic, with a mixed age group of other kids and pick what they're going to do. But, find opportunities for them to set their own goals and try to do it, because that's crucially what they're doing. That's what their control system is in the business of doing. And to some degree, it's using that first 10 to 15 to 20 years of life to lay down, to figure out what the policies are that it can then apply for the rest of your life, right? So the degree that it gets a representative data, right, that's broad, variability, you get variable training over a wide range of different circumstances that can build abstract control policies, that's going to be more durable over a longer period of time for the unanticipated things you encounter later in life when it needs to control the system.
Kind of build in their homunculus.
To some degree, right?
To some degree. Chris?
Well, there's a great, again, these questions are really particularly awesome and pouring in, but a really important one that's highly related, I'll just quote it. Could you please talk a bit about the interaction between childhood adversity, e.g. poverty, and neural mechanisms leading to risk-taking behavior and cognitive control? So, through the lens of what you're just saying, it feels like there's a lot of richness to that.
There is. In fact, I had a collaboration for a while with Dima Amsa, who is a faculty member here, and who's a developmental cognitive neuroscientist. I'm not a developmentalist myself, but I collaborate with them, and our interest in that actually was explicitly trying to understand how the effects of socioeconomic status impact the development of cognitive control. And of course, we were concerned about things like childhood adversity. One thing that struck us, which was very interesting, was that socioeconomic status, of course, it goes across a wide range, right? It's a weird skewed distribution, but that being said, it goes over a whole range, and the relationship between things like crude things like socioeconomic status, which have a bunch of factors in them, right, and performance on tests of cognitive control is fairly linear. In other words, that you see it over the whole spectrum. What you don't see over the whole spectrum is childhood adversity, right? So extremes of poverty and extreme adversity obviously impact those, cause stress, and those have a lot of negative effects. They can get sort of so-called even biologically embedded, in the sense there's some evidence that if you have those exposures very early on, they stay with you. But it doesn't explain that full range, right? Because of all that gradation. What we found was that it was environmental enrichment, which is a good correlate of things like this sort of the ability for variable experience and practice, that was the availability of a wide range of different kinds of learning experiences that seem to be, that explain, and we actually pitted it against stress. We worked with a public health statistician, right? We pitted it against stress in a large sample that we got from around Rhode Island and in the New England area, that it was a better explainer actually than stress over that whole range was environmental enrichment. So it's not to say that it doesn't matter. And of course, negative events can be disruptive, but it's actually not the main driving force is the experiences that you have, or at least that's more common across the whole population.
That's a really neat, interesting. That insight also feels. Is it being applied? Is there an applicability directly to, thinking about learning environments for kids, or is that being adopted in some ways?
Yeah, that's sort of the next stage of this. Is sort of was we just finished this program of work. And I think one of the next stages was to ask what types of enrichment. And we didn't have enough sensitivity in our design to really say conclusive things about it, right? And it's probably not surprising. These things are all correlated. It was shocking to me, not really being in this area, was in the differences in experiences that children have based on just in their how enriched their lives are across sessions. Like one example is just early childhood one-on-one reading time with a parent. The hours spent I forgot the exact number, so I'm not going to make it up right here, but it was on the order of thousands of hours of difference, if I recall, right, between kids in mid to upper SES relative to lower SES. So there's a lot, there's just, and of course, it's just across, all of these different types of measures. These are complex measures. And so it's hard to tie one thing and make a recommendation based on what we saw. But what's striking is that there's something there, right, to pursue, because these differences in experience are so great. And it is a place where I think intervention is very feasible, right? Because you could imagine, if you had a better idea of ways to do that, you could imagine education programs and so forth that aid enrichment. I mean, it's long been known that enrichment matters, but I think things like structured versus unstructured, right, individual goal setting versus not, and so forth, are not as widely explored yet.
Again, dovetailing with this question, but going forward then 60 years, and then moving into the older age category, it's really a really interesting brief question. It's like, how do you change your control system patterns when you were over 70 years old?
Yeah, that's a great point. It's very hard to do, and I think that's actually, coming back to the point we made about what if you think about development as the brain is trying to build a model of its world for the next 60, 70, 80 years, right? Right. You can imagine that without allowing for any just natural changing in the brain, right, through the kinds of changes that happen biologically over the course of our lives. Any of that, you could just imagine that given the entropy of the world, right, the sort of the way things would drift, right, that the world will be a very different place the older you get from the world you had when you were sort of laying down all those policies, right? And so that alone is going to make it harder and harder and harder to apply those kinds of control policies as you get older. And so that's just to sort of lay the problem. So what can be done? I do think that there's not been a lot of there's been some work looking at how older adults use control to sort of identify or aid their the things that happen during healthy aging. And it has been the case that if you find certain types of activities that are that are preserved. For instance, there's certain things that are well preserved in old age, like expertise actually is one of the things that's very robust, interestingly enough, right? It tends to persist, which is maybe good news for some academics. There's a positivity bias as you get older, and both in memory and other aspects of what you do. And what older adults do very well as they get older is they learn to focus their control on things that matter a great deal to them. And maybe it's because you have sort of less capacity to go around, but to some degree they show better allocation in certain cases, right? So in other words, I think I gave you an example. Well, you might be, yes, Aunt Zelda might, occasionally forget, her keys or something, but she's going to be really reliable if you need someone to pick up your kid, right? More so than your 20-year-old cousin might be or something, right? And so there's a because she's going to really focus on trying to remember that goal, right? I think that's really, really important as we get older to bear in mind. The other thing is that we structure our environment to help our control system. Right? One of the things we can do is recognize that your cognitive control isn't like limited to what's inside your head. right? It's embedded in your environment, and you can structure your environment in ways to help your control system even as you get older. And so being realistic about that is a very helpful thing as well, I think.
One of the fabulous things about the book, David, that I think hopefully builds on what you're saying here, is it touches so well on things we intuitively find important and interesting. Like there's nothing disembodied about your book. Like it's not quite a plan of action. It's more of a description of how we might form one or something, like including the early evolutionary history, to your point about it change over the lifespan, but also change over evolution, right? And the kinds of demands we have. How do you think about cognitive control when you do get to the societal level, like as we face challenges going in the future? Are there ways in which there's like, it's almost like behavioral economics, like or an economics principle of how can we act as a bunch of cognitively controlling individuals to either succeed or fail as we face, climate change or other challenges like that?
Yeah, that's a great question. And I think I give the climate change is an example actually I sort of take on at the end of the book, because I think it's an interesting question. I mean, one thing that I think can start with this sort of problem, right, which is that a lot of the focus, at least I feel like around people I know and certainly for myself, has been on people who are sort of denying the science of climate change. Why that's sort of the obstacle to progress, and if we could just convince enough people, we'd all be okay. Which maybe it's true, but I also think that there's another interesting question, which is a large majority of people believe in climate change, right? But far, far more than are actually doing anything in their own lives to do anything about it, right? So the question maybe that interests an activist might be not just about why the people who don't believe it aren't doing anything. Why are the people who believe it? Why are they not doing anything, right? And it's a nice example of the sort of knowledge action dissociation, right? The fact that you can be very aware of the consequences of what will happen if we don't act soon, on this in a much more radical way than we're probably we've been thinking about to some degree, both at an individual level as well as a societal level. And there's some lessons from control on that, both at the individual level and at the societal level. And they kind of pertain to the kinds of trade-offs I was already describing, right, that scale, right, like the flexibility, stability trade-off and so forth. But as just one example, right, probably one major obstacle is that it's a big deal. It's very costly to us, right? Amitai Shinhead here at Brown is one of the world experts in how the brain tries to trade off between the costs of mental effort, right, that are involved in engaging in control, and which would include something like behavior change, and the benefits that would follow. That's a cost benefit analysis your control system is going to do, your brain is going to do. And surely that's a piece of why someone who believes climate change happens, believes it matters, thinks it's an issue, has to decide whether they want to radically change all kinds of components of their lives, stop flying, or perhaps maybe change the way their eating habits, change just a huge range of things in your everyday life. Right, you have to, given what you think the efficacy of that behavior will be, if you're the only one who does it, for example, right, versus, or whether it will really work and so forth. And so, it's something to take into consideration in the policy discussion, right? I mean, I'm not a policy expert at all, so what I know about policy is only what I read from people who I would otherwise trust. But nonetheless, I could talk about it from a control perspective. Something like carbon taxes, or what they would do, right, would be make a very explicit or salient, right, the cost of a particular behavior, right, as opposed to making it, and that would likely have an impact in that kind of trade-off. So those are the ways that I think understanding control affect how our understanding of how society works.
Mm-hmm. It is also, I know you've said this in a different way, but just to come at it from a slightly different perspective, like the enormity of of the challenge is also just mentally exhausting, right? It's like so that it's almost because it's so embedded in every single action that we take, and so it isn't just about one action, it's about pretty much everything that we're doing. And so I don't know if there's a way for you to think about or to present the state that as one scales and something's integrated in every single decision, it's easier to leave it aside, right? Than and to pick and choose. And I think that our colleagues in climate have done a really good job, I think, about picking out those individual pieces. But there may well be, your work might say, you really have to do this because we can't take on the scale of what this means and be able to function every day. So we all make those individual decisions, but there is science there, right, that backs that.
I agree, and I think we're going to learn a lot too, actually, from studying this current crisis, right? The response to the pandemic, because that's, I mean, climate change is pressing, but here we have this thing, you can't be much more, more immediate, right? What's happening with COVID. And you see even now things like pandemic fatigue, right? That you see that there's like this decline in compliance over time from people who, it's not just people who have kind of maybe for a libertarian attitude about the measures that would protect public health, but even people who acknowledge those measures just have a hard time complying and feel it's exhausting to do so, right? And so I think we're going to learn a lot about exactly what you're describing, about how we deal with these large scale problems that might actually be very informative for how we would engage in societal change for something like climate change down the road.
Yeah, one really fascinating chapter in your book is on how hard cognitive, like the work relationship to cognitive control, like how much work it is.
Yeah.
And again, Amitai's work is great in this. Your work is really interesting in this. But that's the feeling sometimes, right? It just would be too much work not to go more automatic or think fast instead of slow. And that, especially in the pandemic, when everything's hitting you and climate change is still an issue, and you have 20 other variables with masks and protocols and working from home, the exhaustion that goes with that's really profound. And again, it's a really particularly cool chapter among a long stretch, obviously, of the whole book, but that seems like such a rich area to consider.
Yeah,
We're
very
getting
salient for us
perilous
these days.
Yeah, to say the least. I believe we're done in a minute or something, which I looked up thinking, oh great, we have another, and it was like, my clock says 11:58. So any last questions, Diane or David, things you wanted to say? Or
I think that we could go on for hours, but we won't. We will capture, just to say, before I thank David, that there's just like this stream of fantastic comments and questions, and I'm going to ask the people behind the behind the video camera if they could capture those questions, and we'll send those to you, David, so you can get to see those. No, again, this was just a thrill.
This was a lot of fun. Thank you.
It was great. I do want, since we're at the end of 2020 Carney Conversations, I'm just gonna first I want to thank you, David.
My pleasure.
It was great. Can't say any more that would capture the fun that we've just had. Again, participation from everybody who dived in. I do want to thank, since we're at the end of the year, everybody who is behind the scenes media services. Like, you guys have just been amazing. And just let us focus on answering questions and having fun. Sarah and John as well for helping to coordinate. I'm just going to announce quickly, like, we're going to continue this series. It's been really, I think, very informative. It allows us to talk to a whole variety of people that we wanted. Chris and I was like, we want to sit down with that person and chat. And see where the conversation goes and where you, as the participants, the audience, take us. But the next discussion is going to be with Bill Martin, who's a PhD grad from Brown, from the Department of Psychology back then, wonderful colleague. And he's the Global Therapeutic Area Head of Neuroscience at Janssen Pharmaceutical Companies of Johnson & Johnson. And he's going to discuss the practical challenges of bringing great scientific ideas to real world solutions. And that will just be tremendous. Bill is just phenomenal. So that's going to be January 29th at 1:30, but you'll get emails about that. Make sure that you go check out David's book. It is phenomenal. Congrats again, David, for this. And I just, the stroke of 12. Thank you all for being here. It was great. Thank you from Chris. Thank you from me. And thank you.
Thanks a lot, David. And make sure you post your sabbatical reading list.
Stay on task, everyone. Bye.